Good day, everyone. So today we are going to be talking about vector and scalar quantity. Now, you know, whenever we are talking about physical quantities and physics, we have fundamental quantities and direct quantities. So physical quantities in physics can also be classified into vectors and scalar. We're talking about vector quantities. These are quantities that possess both magnitude and direction. This simply means that a vector quantity has both magnitude and direction. Examples of these vector quantities include velocity, acceleration, force, impulse, momentum, displacement, electric field intensity. Anything field is a vector quantity. So vector quantities has both magnitude and direction. But we are talking about scalar quantities. Scalar quantities are quantities that has only magnitude but no direction. Scalar quantities has only magnitude but what? No direction. Examples of these scalar quantities include all fundamental quantities. You know, in our previous video, we've explained what fundamental quantities means. So all fundamental quantities, length, mass, time, temperature, luminous intensity, they are all scalar quantity. Distance, speed, density, work, energy, power, pressure, they are all scalar quantities. We can also have other scalar quantities. Now, we are now going to move on to unit vector. Unit vector. Now, whenever we are talking about unit vector, these are vectors that has the magnitude of exactly one. They are vector, they are vector that has magnitude of exactly one. Then these unit vector are basically used to specify directions. Unit vector are basically used to what? Specify direction. Now, what are the unit vectors we have? The unit vectors include I unit vector, J unit vector, and K unit vector. Since unit vector specify direction, then we have to know that I unit vector specify X direction, J unit vector specify Y direction, K unit vector specify Z direction. Then once we've known that unit vectors specify direction, then we've known that I, J, and K are the unit vectors we have. Then you also have known that we have what we refer to as the orthogonality of a unit vector. So if they ask you that what is the orthogonality of a unit vector, the orthogonality of a unit vector simply means what? 90 degree. So the unit vector can be expressed in 3 dimensions as shown. The unit vector can be expressed in 3 dimensions as shown. So this is the horizontal x-axis, this is the y-axis, and if you want to represent the z-axis, this z-axis is represented as this. So for the x-axis, I specify this direction. For the y-axis, J specify this direction. For the z-axis, K specify this direction. So a particular vector can be represented as this. So a vector quantity can be represented as this. So a vector quantity has both magnitude and direction. The I, J, and K are the ones specifying the direction, while the magnitude include the AX, AY, AZ. So a vector has both magnitude and direction. That is why for a vector quantities, we are going to show an arrow like this that shows the what? Direction. So the magnitude of the magnitude or vector, whenever you hear of a vector, can be written as this. So it can be written an ordinary A, or you write it as what? Put it inside bar like this. So the formula for the magnitude of a vector, for example, this vector is x squared with x squared plus y squared plus z squared. This is the general formula for the what? For the magnitude of a what? Vector. The unit vector can also be given as, now there is a way we usually use to compute a unit vector. If you are given a particular vector like this, and you are asked to compute the unit vector of this vector, then the formula for the unit vector, if it is unit vector of vector A, it will be equals to vector A all over magnitude of a vector. So this simply means that if you want to compute the unit vector of a particular vector, you will firstly look for the vector given, then you will also look for the magnitude, then you are going to do vector given over magnitude of the what? Of the vector. Okay, guys, so we will now talk about the operations of unit vectors. The various operations of unit vectors include addition of unit vector, subtraction of unit vector, and multiplication of unit vectors. Now let's talk about the addition and subtraction of unit vector. Whenever we are talking about the addition or subtraction of unit vector, this is done by adding or subtracting similar unit vectors together. Let's look at some example. The example include is that if vector A is equals to 2y plus 3j plus 4k, and vector B is equals to 5y plus 2j plus 3k, find the following. These are the various type of question you might be asked in this particular question. Find the following: magnitude of A, magnitude of B, magnitude of A plus magnitude of B, magnitude of A minus magnitude of B, A plus B, A minus B, magnitude of A plus B, magnitude of A minus B, unit vector of A, B cap. Don't forget that B cap simply means what? Unit vector of B. And also unit vector of A plus B. Now, guys, let's look at the solution. Now, guys, if vector A is equals to this, number one, if vector A equals 2I plus 3J plus 4K, then the magnitude of vector A would equals square roots. So whenever you're looking for the magnitude of vector A, you're going to write a square root, then you're going to be adding the square of each coefficient of I, J, and K. Everybody, what is the coefficient of I here? That is what? 2. So this will just be 2 put inside a bracket, square. Then you're going to place plus here. Now, the coefficient of J here is what? Is 3. So this will also be what? Open bracket, 3, close bracket, square, plus the coefficient of K here is also what? 4. So this also be what? 4, open bracket, square. So guys, listen. Let's say, just for an example, let's say that vector A was equals to 2I plus 3J plus 4K. Sorry, minus 4K. Let me say 2I minus 3J minus 4K. And you may asked to look for the magnitude of vector A. What you're going to do here will just be square root. The coefficient of I here is 2. So that will just be 2, put inside a bracket, square. You are going to put plus. You will open another bracket. What is the coefficient of J here? That is what? Minus 3. Minus 3 all squared. You will also put plus. What is the coefficient of K here? Minus 4. Minus 4. You will also put what? All squared. So you have to be very careful whenever you are looking for the magnitude of a vector. You have to know that if what is there is plus, then you are going to do it like this. And if what is there is minus, you are going to do it like this. Always open your bracket and put the coefficient inside the bracket. But whenever you want to combine this with this, what should be here should be plus. This with this, what should be here should be plus. But each coefficient should be put inside the what? Bracket and what? And square it. So guys, the magnitude of A would then equal square root. What is 2 square? 4. Plus 3 square, 9. Plus 16 square. Oh, sorry, 4 square, 16. Then 4 plus 16, that is what? 20 plus 9. So the magnitude of A is equals to root 29. Now, for number 2, if vector B is equals to this, vector B equals to 5I plus 2J plus 3K, then the magnitude of B will just be square roots. The coefficient of I is 5. This will be 5 all squared. Plus, open another bracket. The coefficient of J is plus 2. This will be 2 all squared. Plus the coefficient of K is 3. This will be 3 all squared. So the magnitude of B would then be, what is 5 squared? 25. Plus 2 squared, 4. Plus 3 squared, 9. So 25 plus 9, that is 35. Then 35 plus 4, that is what? Sorry, 25 plus 9 is 34. 34 plus 4 is what? 38. So the magnitude of B is what? Root 38. So that is that about that, guys. Now the question now asks us to look for magnitude of A plus magnitude of A plus magnitude of B, magnitude of A minus magnitude of B. Now, if you want to look for the magnitude of A plus magnitude of B, then this would equals root 29 plus root 38. And if you want to look for the magnitude of A minus magnitude of B, then it will be equals root 29 minus root 38. Then you can simplify your what? Your answer. That is that about that, guys. Now, let's move on to A plus B, A minus B. So guys, now we are going to look at the A plus B and A minus B. You know from the question, our A is this, our B is this. Now I want to do A plus B. So we firstly write out the vector A. This is vector A plus vector B. This is vector B. A plus B. This is vector A. This is vector B plus vector B. So whenever we are doing A plus B or A minus B, we usually add similar unit vectors together. That is, we are going to look at vector A, we are going to look for vector B. Vector units that are similar, unit vectors that are similar to each other, we are going to add them together. This is 2i, this is 5i. So this will be 2i plus 5i. We are going to open the bracket, open bracket, 2i plus 5i. Then you are going to place plus here. You will then go to j, 3j plus 2j, close bracket, place plus here, go to k, 4k plus 2k, close brackets. Now we will now do 2i plus 5, that's what, 7i, 5j plus 6k. Now the same approach will be done for A minus B, but we are doing A minus B. We are going to be subtracting similar unit vector from each other. This is vector A, this is vector B. Then we want to look at A minus B. A minus B. Now we are going to be subtracting unit vectors from each other. So we are going to open brackets for I, 2i minus 5j. So inside the bracket, you are going to write 2i minus 5j. You will close bracket. Then you are going to place plus here. This plus that we place here is a what? Is a combining tools. Whether you are doing addition or you are doing subtraction, outside the bracket, what you are going to be placing should be what? Plus. Do you get that? So you are going to open another bracket for j, 3j minus 2j. Close the brackets. Then place another plus outside the bracket. Open another bracket. Then 4k minus 2k. Close the bracket. So this will give us minus 3i. This will give us j. This will give us what? 2k. So guys, the next one is we should look for the magnitude of A plus B, magnitude of A minus B. This particular question, magnitude of A plus B, you have to know that the magnitude of A plus B is not equal to the magnitude of A plus magnitude of B. So if you want to look for the magnitude of A plus B, you will firstly do A plus B. Then you are going to look for the magnitude of the overall A plus B. But if you want to do magnitude of A plus magnitude of B, you will firstly look for the magnitude of A, and also look for the what? Magnitude of B. So the magnitude of A plus B. So we will firstly look for A plus B. Our A plus B is given as this. So therefore, the magnitude of the A plus B will now be given as square roots. Now, the coefficient of I is what? 7. 7 square plus for j is 5. 5 square, and for k is what? 6. 6 square. So that is how we are going to do the what? The magnitude of A plus B. So we will first do our A plus B before we look at the square root of the coefficient. Now this would be 7 square is 49. 5 square is 25. And 6 square is 36. So 49 plus 25 should give us 74. 49 plus 25 will give us 74. Then 74 plus 36, that will give us what? 110. So this equals what? Square root 110. Okay, for the magnitude of A minus B, we will firstly do A minus B. Our A minus B is this. This is the value for our A minus B. This will be equals to the square root. What is the coefficient of I in A minus B? That is what? Minus 3, open bracket. Minus 3 all squared plus coefficient of J, that is 1. 1 squared. Coefficient of K, that is 2. 2 squared. So this will then equals to square root. Minus 3 squared is 9. Plus 1 square is 1. 2 square is 4. So this will be what? Square root 14. So that is that about what? About that, guys. So guys, in the next question, we have to look for the unit vector of A. Now, in the question, vector A was given as this. Vector A was given as this. But don't forget that we have originally calculated the magnitude of vector A to be equals to this. So the unit vector of A can be written as A cap. So unit vector of A is A cap. This simply means cap. So this is unit vector of A. And it is equals to vector A all over the magnitude of the vector A. Our vector A is given as 2i plus 3j plus 4k. And the magnitude of vector A has been calculated to be what? To be root 29. Root 29. So this simply means that you will firstly calculate the magnitude of vector A. Then once you've done that, you are not going to what? Write it as this. Then the final answer can be written as 2 over root 29I plus 3 over root 29J plus 4 over root 29K. So this is the final answer. And if you like, you can what? You can simplify further. So let's look at the next one. So in this example, we have to look for the B cap. Don't forget that B cap simply means the unit vector of B. So don't forget that initially our vector B was equals to 5i plus 2j plus 2k. From the question, our vector B was given as this. And we have calculated our magnitude of B to be this. Then our B cap can be equals to vector B all over magnitude of vector B. Vector B from the question is 5i plus 2j plus 2k all over magnitude of vector B has also been calculated as root 38. Then the final answer would then be 5 over root 38i plus 2 over root 38j plus 2 over root 38k. So if you wish, you can also simplify further. Okay, let's look at the last question, guys. Guys, the last question given to us is that if unit vector, we should calculate unit vector of A plus B. If the vector A is this and vector B is this. Now don't forget that we have already calculated our A plus B to be this. Don't forget that in this particular question, what the question is asking us to calculate is the unit vector of A plus B. So this simply means that we have to firstly do the addition of A and what? And B. So the addition of A plus B gives us this. So the unit vector of A plus B will now be equal to vector A plus B all over magnitude of vector A plus B. So our A plus B was given as this, and the magnitude of vector A plus B has also been calculated to be this. The magnitude of vector A plus B has been calculated as square root 110. So therefore, the final answer for this will then be 7i plus 5j plus 6k all over square root 110. Then the final answer can then be written as 7 over root 110i plus 5 over root 110j plus 6 over root 110k. So this is the final answer. If you wish, you can also what? Simplify this expression. So kindly do the next classwork that's going to be given to you. Thank you, guys.